class. Today we're going to be talking about section 4.6, the quadratic formula. And this will just be page 1 of the notes. As you can see that this also includes the discriminant, which we will talk about next time. We'll start with the standardized test practice problem. And it says, find the value or values of k in x squared plus kx plus 100 equals 0 that would make the left side of the equation a perfect square trinomial. So this is what we did in section 4.5, completing the square. Remember that this number, or this number, is the square of half of the middle. This has to be k over 2 squared has to equal 100. So what we do first is we take the square root of both sides. So we will have k over 2. Now it could equal 10 or negative 10, but since this is positive, we're just going to call it 10. Positive 10. And then we would just multiply by 2. So k would equal 20. So the answer is C. Okay, so I'm going to give you the quadratic formula, and what we're going to use it for is quadratic equations that are written in the form ax squared plus bx plus c equals 0. And I will tell you that included in Wisdom, I have a link to the quadratic formula song that was based on the lyrics of Adele's song Rolling in the Deep. Please check it out. I think you'll really like it. It's a great way to help you remember the quadratic formula. So having said that, the quadratic formula is this. It's the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. So what we do is we take our equations and we first identify a, b, and c, which hopefully y'all are all used to doing by now. A is 1, b is 10, c is 24. So we write it out, the opposite of b, which was 10, plus or minus the square root of 10 squared minus 4 times 1 times 24. Now if you're getting lost, follow along with the formula up here. All divided by 2 times 1. Okay, so what we would do is we would take negative 10 plus or minus, and you can put the part in your calculator, you can put in 10 squared minus 4 times 1 times 24 if you want to. I'm just going to work it out step by step, but I don't mind if you want to use the calculator to help you simplify these. This would be 100 minus 96, all divided by 2. So we would have negative 10 plus or minus the square root of 4, all divided by 2. Well, the square root of 4 is 2, so we're going to have, our two solutions are going to be based on the following. Negative 10 plus 2 over 2, and negative 10 minus 2 over 2. Well, the first one would be negative 8 over 2, which is negative 4. And the second one would be negative 12 over 2, which would be negative 6. So in other words, as in the other sections of chapter 4, these two solutions, when each of them are plugged in, to the equation for x will give you 0 as the answer. All right, on B, our A term is 1, B is 2, C is negative 35. We take the opposite of 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 35, all divided by 2 times 1. So we'll have negative 2 plus or minus the square root of 4 plus, I believe that's 140, all divided by 2, negative 2 plus or minus the square root of 144, all divided by 2. The square root of 144 is 12, so this would be negative 2 plus 12 over 2, and negative 2 minus 12 over 2. So this would be 10 over 2, or 5, and the second one would be negative 14 over 2, or negative 7. And if you're in doubt about your answers, try them back in and make sure they give you 0. Remember, when to do that, you would take and you would work this through as with 5 for x, then work it a second time with negative 7 in for x. Okay, let's try example C. All right, so on C, A is 1, B is negative 11, and C is 24. So we're going to take the opposite of negative 11 plus minus the square root of negative 11 squared minus 4 times 1 times 24, all divided by 2 times 1. Simplify, the opposite of negative 11 is 11, plus minus the square root of 121 minus 96, all divided by 2. 121 minus 96 is 25, so we will have 11 plus minus the square root of 25 over 2. So we'll have 11 plus 5 over 2, and 11 minus 5 over 2. 11 plus 5 is 16, divided by 2 would be 8. 11 minus 5 is 6, divided by 2 would be 3. So far we've had perfect squares each time, where in the square, we could find the square root of the number under the square root. On example D, we're not going to have a perfect square this time, so we're going to have to break this down like we did when we talked about complex numbers. So on this one, again, we'll label A, B, and C. A is 1, B is negative 10, and C is negative 50. We'll take the opposite of negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times negative 50, all divided by 2 times 1. So we'll have 10 plus minus the square root of 100 plus 200, all divided by 2. 100 plus 200 would be 300, so from here we would have 10 plus minus the square root of 300 all divided by 2. Now, we don't want to leave our answer like this, and we don't want to write them as decimals, so we want to think of the number 300, and think of the largest perfect square that goes into 300. That's 100. So if we take 300 divided by 100, we would get 3. So I'm going to rewrite this as square root of 100 times square root of 3 before I finish simplifying. So I'm going to have 10 plus minus the square root of 100 square root of 3 all divided by 2. The square root of 100 is 10, so I'm going to have 10 plus minus 10 square root of 3 over 2, and when I simplify I can divide both 10s by 2, so I will have 5 plus 5 square root of 3, and I'll have 5 minus 5 square root of 3 as my answers. Okay. On E, we are going to end up with a complex number, so we will simplify like we did when we worked with complex numbers and break down like we did on this one, so that we can get as large of a perfect square factor out of the square root as possible. So we have A is 1, B is negative 6, and C is 21. So we'll have the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 21 all divided by 2 times 1. 6 plus minus the square root of 36 minus 84 all over 2. And 36 minus 84 is going to be negative 48. So from here we'll have 6 plus or minus the square root of negative 48 over 2. Now there's a couple of things I'm going to do. I'm going to take out the negative and replace it with an I in front of the square root. And I'm also going to take 48 and rewrite it instead of the square root of 48, but as the square root of 16 square root of 3. Because 16 times 3 is 48, and 16 is the largest perfect square that goes into 48. So then that enables me to break this equation down, this number down, complex number down, so that it's not a decimal. And again, remember, we don't want decimals. So what I just said is this. We'll have 6 plus minus I, that replaces the negative, square root of 16, square root of 3. Again, that's equivalent to 48, all over 2. So then we can break down, we can rewrite the square root of 16 as 4. So this will be 6 plus or minus 4i square root of 3 all over 2. So now we just want to divide the 6 and the 4 by 2. So we'll have 3 plus 2i square root of 3 and 3 minus 2i square root of 3. Okay, and on the last one, I want you to call to your attention that it's not set equal to 0 first. So our first step is going to be to rewrite this set equal to 0. That means we would have a minus 14 on the left side. So our equation should be x squared minus 5x minus 14 equals 0. Now we can write our A, B, and C. A is 1, B is negative 5, and C is negative 14. So we'll take the opposite of B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So we'll have 5 plus minus the square root of 25 plus 14, let's see, 56 over 2, and 25 plus 56 would be 81. So we'll have 5 plus minus the square root of 81 over 2. Now that's going to simplify to 5 plus 9 over 2 and 5 minus 9 over 2. 5 plus 9 is 14 over 2 would be 7. And 5 minus 9 is negative 4 over 2 would be negative 2. So that gives you several examples of using the quadratic formula. And again, please go watch the video on the Rolling in the Deep song. I really think you'll enjoy it, and it will be a great tool to help you to remember the quadratic formula. That's it for today. I'll see you next time.